Good morning, everyone. My name is Leming Shen, and I am from the Hong Kong Polytechnic University. It's my second time attending MobiSys, but this time I will not present my paper, but help my colleague Kaixin Chen from Hong Kong University of Science and Technology, Guangzhou, to present their work, PIT, a novel toothbrush providing real-time and robust plaque indication during brushing. And this work is in collaboration with HKUST and the SZU. So do you guys know that we are actually brushing off our teeth every day? And that is called dental plaque, which is a microbial biofilm that continuously accumulates on human teeth. It ultimately evolves into either dental caries or calculus. Thus, the fundamental objective of toothbrushing is to mechanically disrupt this biofilm during its initial formation phase. However, even with careful brushing, ordinary people still have approximately 10 to 20% of plaque remaining on their teeth. And to facilitate complete plaque removal, plaque disclosing agents serves as gold standard for visualizing invisible biofilm, enabling targeted oral hygiene procedures. Plaque disclosing agents are recommended by over 50% dentists for use by the general public before brushing, particularly for individuals who need extra attention to their oral hygiene. So for example, those with severe dental issues like caries, children and the elderly with limited brushing skills, or patients with braces to help them thoroughly remove plaque. However, existing toothbrushing fail to integrate with disclosing agent applications, focusing users to use mouth opener or oral endoscope to monitor plaque removal efficacy. And this means that they might have to rinse several times to clear away foam and keep switching between the toothbrush and endoscope or opener to get their teeth completely clean. So, we propose a novel visual toothbrush, PIT, which enables real-time plaque visualization during brushing after applying a disclosing agent. This guides effective plaque removal and promotes scientifically optimized brushing. However, we face two challenges in PIT development. First, designing a novel toothbrush architecture that seamlessly integrates a micro camera and LEDs for real-time visualization. If the circular PCB is simply placed at the bristles, it will rotate with the bristles, causing the captured image to become significantly blurred. And moreover, we must avoid introducing sharp mechanical structures that may rub against the user's mouth to ensure comfort. To address the challenges and meet the design requirements, we designed the following mechanical structure. A circular PCB with a hollow shaft and a central hollow bristle, a shell with dual cavities, and a toothbrush handle with a horizontally linear vibrator. And then the main assembly points are like the cavity shell is fitted in a stable position of the handle below the vibrator. The groove of bristle section is fitted onto the vibrator of the toothbrush handle. An umbrella-shaped circular PCB section is mounted onto the shell's supporting shaft using a tunnel and a mortise structure, forming a rigid connection, thus keeping camera and LEDs relatively stable to use the brush handle. So this cavity shell features a large conduit that accommodates the vibrator and separates narrow conduits for the wires. The second challenge is that during brushing, toothpaste foam gradually covers the teeth, making it challenging to sense plaque beneath. And achieving robust plaque segmentation despite foam occlusion during brushing is challenging. So to address this, we first model the effect of foam and the tooth surface on light, which led us to reduce the plaque patches reflection coefficient and increase light intensity. Thus, we tested LEDs with different wavelengths and selected the green light LED. This is because the purplish red dental plaque reflects the least green light, making the plaque patches appear almost black, enhancing the distinction between the clean tooth and plaque patches. Though this light source wavelength selection, we minimize the dental plaque reflectively. On the other hand, we use the higher drive voltage to increase the light intensity, thus enhancing the contrast between the reflected light intensities of the clean area and plaque patches. And also, we must consider the light intensity range that the camera's CMOS sensor can handle. However, detecting two surfaces in dense form remains difficult. And based on the aforementioned contrast enhancement technology, identification can be achieved under some thin and large foam occlusions. However, in densely formed areas, the stained patches beneath the foam remains invisible. And inspired by context encoders, we treat foam occluded areas as missing pixels and sparse foam regions as visible. Thus, we propose a deep learning model for plaque segmentation and mask generation. Moreover, since we expect users to run our model inference on a ubiquitous smartphone in real time, we adopt the knowledge distillation method to obtain a compressed student model. Since brushing removes plaque, making it impossible to align the captured image with pre-collected ground truth data, we used a denture model and waterproof coating for testing. We collected a total of 400 paired images, and we calculated the recognition accuracy using 5-fold cross-validation. Our experimental results show that we can achieve 75% accuracy by only using the student model, and the image below shows the visual results. And we also show that the light source design can improve the accuracy. In terms of robustness, we also demonstrated that PIT is robust under different toothpaste agents and ambient light. And in the human subject study, we further demonstrate how users can interact with PIT and investigate its impact on users. 10 users use our toothbrush and the most advanced commercial toothbrushes that can monitor 16 teeth areas. The results show that when using PIT, the average plaque level dropped to 5.6% with an average reduction of 84.5%, showing higher plaque removal ability. And also, the users considered our PIT as equally comfortable as commercial toothbrushes. Despite reduced convenience scores due to agent use, participants' daily usage intention remained high, primarily driven by the plaque visualization benefits. However, as a proof of concept prototype, the system needs further iterations, including the interaction design, bristles, replacement, wireless data transmission, as well as training data set expansion. And for more details, please refer to the paper. And if you have any questions, you may contact the author through the email. And thanks for listening.